Okay, so here we have a question looking at the required practical for specific heat capacity, the first one that you see in physics. So let's have a look. It says, a student investigated how the temperature of water changed as it was heated, and the figure below shows some of the apparatus used. So you can see this power supply is connected to the electric heater, that then heats up the water within the beaker, and you're recording the temperature using the thermometer. Okay, so fairly simple experiment, hopefully. The students now switched on the heater and recorded the temperature of the water every 5 minutes, and the table below shows the results. And they've said, what is the resolution of the thermometer used in the investigation? Use the table above. So we need to look at the results. The resolution is referring to how precisely the recording can be made to. So basically the precision of the actual instrument. So in this case, the thermometer. Yeah. So each of these measurements is saying either 0.1 degrees, 1 degrees, 10 or 100 degrees. So the smallest increment we can see is not quite 0.1. You don't see any decimals there. So it's just whole numbers. So therefore, the smallest increment and therefore the resolution is 1 degree C. Now the next question says calculate the mean value X in the table. So we can see this is the mean at 10 minutes during the experiment. So we have 3 tests because they've repeated it 3 times. So we're going to take those results and calculate an average. So in order to do that, you sum up the results. So that's 42 plus 45 plus 45. And then you divide that by the number of results, which is 3. Okay, so that is equal to total at the top being 132 divided by 3, giving you a value of 44 degrees C. So I'll go ahead and pop that there. Quite an easy 2 marks. Then it says draw a ring around the anomalous result. Now here, this should be easy to spot because it should be the result that doesn't look like the others than when they repeated the test. So saying this, if I have a look, the top row, they're all 25, exactly the same. They've done pretty well there. The second one, there's only a range of 2 degrees C, pretty close, that's fine. Similarly for the third set of results, it's a difference of 3 degrees, not big. So you can see here, we do notice it, 56, 54, and then 64. It's 10 degrees out from the others. The other two are only 2 degrees apart. So my anomalous result, I'll circle it in red, that is 64 degrees. Okay, so that's our unusual result. Remember, it's the outlier to what we're expecting to see. So now it says, what should the student have done with the anomalous result? For 1 mark. So you can see from the table, they've actually included it when calculating the average. They shouldn't have done that because obviously it's now skewed their average by quite a bit. So what they should say, simply here, all we need to say is that we remove or do not include the value when calculating the average. So exclude it when calculating the average. Now the next question is about the experiment itself, and it says give 2 ways to reduce energy transfer from the apparatus to the surroundings. So remember, this is a heating experiment. So we're trying to heat up the water and we don't want to heat up the surroundings because that can skew the results, right? So there are 2 things we can look at, either around the beaker because it can go from the beaker to the surroundings, or directly from the water to the surroundings because the top is open. So starting with the first one, if we want to keep the beaker from releasing heat to the surroundings, we would say insulate the beaker. And for the second mark, if we want to protect from water escaping from the top of the beaker, we can simply put a lid on top of the beaker. So I'll say put a lid on the beaker for the second mark. So our next question is a calculation question, and it says the water in the beaker has a mass of 0.20 kilograms, and it says the temperature increase is 33 degrees Celsius, and it says the specific heat capacity, which is a constant, which we've probably seen before, is 4200 joules per kilogram degrees Celsius. Calculate the change in thermal energy of the water using the equation which they've given us. Change in thermal energy is mass times specific heat capacity times by temperature change. And it says determine the unit from the box below. So getting the unit is specifically a mark here, okay? Out of the 3 marks, 1 of them is for this. Now we can find that out easily because it tells us we need to calculate the change in thermal energy. Energy being the key word, the unit for energy, we've seen it before, it is joules. So I'm going to circle that and put that at the bottom. So we've got 1 mark already guaranteed. Now we need to determine what each of the numbers they've given us are so we can use it in the equation. So I'm going to put letters next to each. The mass is 0.20 kilograms, so that's M, and it says the temperature increase, suggesting a change in temperature. It's 33 degrees Celsius, so that's going to be my delta theta for change in temperature. And then lastly, the last number is specific heat capacity, so that is going to be the letter capital C. And they want us to calculate the change in thermal energy. That is our unknown, delta E. So using the equation, we were just working out the thermal energy. So we can keep the equation as it is. I'll do it in letter form. Delta E equals mc delta theta, and then we sub in our values, so that is 0.20 times 4,200 multiplied by the 33 degree temperature increase. You put in that into your calculator, you get a value of 27,720 joules. So put that in the box. 2 marks for subbing into the equation correctly and getting the correct answer, and then 1 mark for the unit, so 3 marks. Now the last question says explain what happens to the mass of the water in the beaker during the experiment. So when it is heated, remember we are heating the water, water could potentially evaporate, right? So the first mark is for the water being evaporated, and as a result of that, if it's evaporated, that water is no longer there, so then there's less water left and the mass decreases. So there we have it, a complete question on specific heat capacity required practical, quite a long one with a variety of different things on both the experiment as well as calculations and explanation questions. So a tough one, all in all about 12 marks, but a really good way to get good marks if you know the experiment very well.